Welcome you all. It's me, Amith Shabu from Mechanical Batch X5. I am going to say the topic about cryogenic engine. Now we will say about the introduction of cryogenic engine. A cryogenic engine is also called as rocket engine. It can be used as a cryogenic fuel. Fuels that requires storage at extremely low pressure in order to maintain them in a liquid state. Various cryogenic fuel oxidized combinations have been used, but the combination of liquid hydrogen fuel and the liquid oxygen oxidizer is mainly used and it can be widely used. It is the diagram, one of the diagram of cryogenic engine. V is represented as velocity, M mass flow rate, P pressure. The formula of thrust is F is equal to mve plus Pe minus P0 into A. Now we will talk about the principle of cryogenic engine. Basic principle driving a rocket engine are Newton's third law and law of conservation of moment. The mainly used as Newton's third law of motion and law of conservation of motion. Okay. In cryogenic rocket engine derives thrust like all other rocket engine by accelerating and impulse carries to high speed. The chemical stored in the fuel is converted into kinetic energy by burning the fuel in thrust chamber and subsequent expansion in the nozzle to produce thrust. Mm. Now we will know about the history of cryogenic engine. Uh, American and Soviet engineers are mainly discovered the rocket engine need with high mass flow rate of both oxidizer and fuel to generate a sufficient thrust. At that time, oxygen and low molecular weight hydrocarbons were used as oxidizer and fuel pad. At room and pressure, both are in gaseous state. Hypothetically, if propellants had been stored as pressurized gas, the size and mass of the fuel tank themselves would severely decrease rocket efficiency. Therefore, to get the required mass flow rate, the only option was to cool the propellant down to the oxygen cryogenic temperature, converting them to liquid form. Hence, all cryogenic rocket engines are also by, by definition either liquid propellant rocket engine or hybrid rocket engines. We will see it is the diagram of RL10 engine. Now we will discuss about that. RL10 was the first liquid hydrogen cryogenic rocket engine to be built in the United States and development of engine by Marshall Space Flight Center and Pratt and Whitney began in 1950s with the first flight occurring in 1961. Their engineers. These engines were one of the main factors of NASA's success in reaching the moon mm, by RL-10 engine rocket engines. Next, we will talk about LPC Mahindagiri. Uh, it is renamed as the Indian Space Research Organization Population Complex, and it is on February 2, on 1st February 2014 and was also made on autonomous department under ISRO. The main activities is carried out here. Assembly and integration of liquid engine and stages. Testing of liquid engine and stages. High altitude test facilities for upper stage engines. Propellant storage facilities. It is the it is one of the diagram of not a diagram. It is a picture of ISRO propulsion complex Mahendagiri. It is one of the place called Mahendagiri, situated in Mahendagiri. It shows the picture of cryogenic rocket engine CE 7.5. We will let's discuss about the specifications and characteristics of this engine. It is a staged combustion operating cycle. Propellant combustion is liquid oxidizer. Maximum thrust is 75 kilonewton and operating thrust range is up to 73.55 kilonewton to 82 kilonewton. Okay. Next we will chamber pressure 78 bar, engine mixture ratio 5.0, then engine specific impulse force 54 plus or minus 3 seconds. Engine burn duration 720 seconds. Propellant mass is 12,800 kg. Two independent regulators, thrust control and mixture ratio control. Steering duration thrust is provided by two grim-bladed steering engines. It is the picture of CEO 20. Stop it. It is a picture of CE20, which is one of the cryogenic engine also. The specification of this engine is opening cycle is gas generation, potential combination is liquid oxidizer, thrust nomination 2200 kN, operating thrust range is up to 180 kN to 220 kN, chamber pressure 6 MPa, engine mixture ratio is engine mixture ratio is 5.05, engine specification in plus 443 plus or minus 3 seconds. Engine burn duration 595 seconds. Total flow ratio 62 kg per second. Nozzle air ratio 100. Mass 588 kg. Now we will describe about the construction of cryogenic engine. The major component is the convection chamber, cryotechnic initiator. Okay. Now we will describe about the construction of cryogenic engine. The major component of cryogenic engines are convection chamber, cryotechnic interior, fuel injector, fuel cryo pump, fuel cryo pump, oxidizer cryo pumps, gas turbine, cryo valve, regulator, the fuel tank, and the rocket engine notion. It has two type of propellant, liquid propellant and solid propellant. It is the board diagram which shown in this webinar. Now next we will say about next diagram. It is a part of a liquid rocket engine which consists of fuel tank, pump, combustion chamber, oxidation tank, igniter, nozzle. It is the main part of the cryogenic engine. It is the main diagram which consists of fuel tank, oxidizer tank, pressure gas, heat exchanger, pressure feed system. Another one, pump feed system, is which consider same as fuel pump, turbine, oxidizer pump, then heat exchanger. Okay. Next, it is the important diagram of cryogenic engine. In the parts are labeled in this diagram. Now we will discuss about the advantages of cryogenic engines. High energy per unit mass. Propellant Propellant like oxygen and hydrogen in liquid form gives very high amount of energy per unit mass, due to which the amount of fuel to be carried abroad the rocket increases. Clean fuel. Hydrogen and oxygen are extremely clean fuel. When they combine, they give out only water. The water drawn out of the nozzle in the form of very hot vapor. Thus, the rocket is nothing but the high burning steam engines. Next one, economical. Uses of oxygen and hydrogen as fuel is very economical, as liquid oxygen costs less than gasoline. In this page, we will see all the comparison of cryogenic engine. Solid fuel advantages. We very stable, durable fuel system is simple, safer, and cheaper. More trust for similar rocket size. Next comparison is about solid fuel disadvantages. Can't be turned off once the burn starts. It goes uh, on until the fuel is used up. Low efficiency fuel decomposes, must be replaced. Liquid fuel advantages. Various thrust, the amount of fuel and rate of burn can be changed in flight. Relatively high efficiency. Liquid fuel booster are more easier reusable. Disadvantage of liquid fuel. Uh, Fragile, more complex parts, highly complex system, and require high maintenance. Oxi- Oxidizer must be kept extreme cost. Now we will tell about the disadvantage of cryogenic energy. Cryogenic liquids difficult to store for longer period. High density requires larger tank. High reactive gases. Leakage problem. Boil off rate. Hydrogen membrane. Zero gravity. Now we will say about the application of cryogenic fuel. Liquid nitrogen used in cryotherapy as a coolant, cryonic radiation. Nuclear magnetism resonance spectroscopy. NMR is one of the most common methods to determine the physical and chemical properties of atoms by detaching the radio frequency above and subsequent relaxation of nuclei in the magnetic field. Frozen food. Cryogenic gases are used in transportation of large mass of frozen food. Blood banking. Certain rare blood groups are stored at low temperatures such as minus 165 degrees Celsius. Thank you to all. Bye bye.